Today again I'm here to solve physics question paper unit 1. You can check this. Sorry, unit 2. Okay, it's my mistake. It was unit 2, physics unit 2, and topics are waves and electricity. And in this paper you can use scientific calculator, ruler and protector. Okay? And below you can read instructions, information, and the total mark for this paper is 80. And you can read this advice also. Now see, section A, answer all questions. For questions 1 to 10 in section A, select one answer from A to D and put a cross in the box. If you change your mind, put a line through the box like this and make like this, and then mark your new answer with a cross like this. Okay, so first question is, which of the following units is equivalent to the volt? If you remember, volt formulas are V is equal to IR. This is called voltage and its unit is volt. This is called resistance and its unit is ohm, and this is called current and its unit is called ampere. So from here, and this law is known as Ohm's law. And one more formula we have where V is equal to work done divided by charge. So from here you will get voltage is equivalent to ampere ohms, but from this formula you will get volt is equivalent to work as joules and this is coulombs. So you can write this as joules per coulomb. So from here correct answer is C. Now question number 2. The de Broglie wavelength for a moving electron is this. Okay, which of the following expression gives the speed of electron in meter per second? So first of all, what is de Broglie wavelength? Okay, what is de Broglie equation? According to de Broglie wavelength formula is P h by P. This is h by P. This h is called as Planck constant and this is called as momentum. Okay, and you can also rewrite this formula h by, and P is momentum, and momentum is a product of mass into velocity or mass into speed. So from here you can write P as m into v, and you can interchange v and lambda for getting speed of the electron. So v here and h by m into lambda. Now you can substitute the values of respective of symbols. You can use the values of these terms. H is Planck constant and its value is 6.63 into 10 raised to 34 joules per second with units, and the mass of electron is 9.11 into 10 raised to minus 31 kg. Okay, and this is lambda. Lambda is already given to us, and lambda is equal to 5.74 into 10 raised to minus 10 meters. And after substituting all these three values you will get your answer. So in numerator you will get only h value, means 6.63 into 10 raised to minus 34. So from here you can neglect C and D, okay, because only A and B option has this value in above. And in denominator you have mass into lambda. So this is the value of charge, 1.6 into 10 raised to minus 19. So from here this is the mass of electron, this is the wavelength, and this is the h. So A is our right answer. Okay, now question number 3. The diagram shows a cell of EMF, the epsilon and internal resistance R. The cell is connected in series with two resistors of resistance R1 and R2. The potential difference across R1 is V1. The current in the circuit is I. Okay, the total current in the circuit is I. Now it is moving in this direction because current originates from positive terminals or higher terminals. Okay, and it goes like this. Which of the following expression is correct? Okay, which of the following expression is correct? So according to sign convention, if this is minus negative terminal and this is positive terminal, and we know electrons is moving in this direction, so direction of elect in the direction of current in the direction of current, voltage drops. In the direction of current across the resistor, voltage drops. Okay, so what we can write here, if we can use here, okay, law, that is KCL. Okay, you can use KVL here, KVL law. So at this point you can write this as the you can write the epsilon as if we will write this point as A, so voltage of A, this is minus of I R1, this is minus of I R1, and this is minus of I R2, this is the minus of I R, this is the gain of epsilon, and it is equal to VA. Now this and this gets cancelled, so from here epsilon is equal to, and you can write here this one as V1, so this is going to be V1 plus I R2 plus I R, okay, plus I R. So you can write here from here, you can write here correct answer as D, because epsilon is equal to V1 plus I R2 plus I small r. Okay, question number 4. As temperature increases, resistance of a negative temperature coefficient thermistor changes. Which of the following describes the reason for this changes? Okay, so first option is collision between electrons and ions occur less frequently. Option B, more conduction electrons are released. Option C, the ions in the thermistor vibrates less. The ions in the thermistor vibrates more. First of all, thermistor is what? Semiconductor. Semiconductor. And in semiconductor, there is, okay, it is semiconductor have properties of metals as well as non-metals. Non-metals. So if you will increase the temperature of semiconductor material, so the number of electrons will jump from Okay, the energy bands, the electrons will jump, so you can say more conduction electron are released. B will be correct answer, because as you will increase the temperature, electrons, okay, free electrons will increase, and as the free electrons will increase, the negative resistance temperature coefficient changes. That's why the resistance will changes. Okay, so you can mark B as a right answer for question number 4. Okay, question number 5th. You can refer question number 5th and 6th for the following information. The diagram shows rarefaction of a light. Rarefaction of a light as it passes through the three transparent substances L, M, and N. The speed of light in three substances are VL, Vm, and Vn respectively. Means here the speed of light is VL, here is Vm, and here is Vn. Which of the following shows the relationship between VL, Vm, and Vn? Okay, so which one relation is correct? Okay, so first of all, what is the question we have to, okay, understand it. Here you can see the light is bent towards what? The light bends towards normal, and here the lights bends away from the normal. So which of the following option can be correct? Because in first case, this is bending, the light is bending towards normal, so this medium is rarer medium, and this medium will be denser. And when the light moves from rarer to denser and it bends towards the normal, it means this is rarer and this is denser. And in rarer, the speed of light is faster than the denser medium. So you can say VL is greater than VM. And in this case, the light is traveling away from the normal. Away from the normal means what? This is denser and this is rarer. So this is denser and this is rarer. It means you can say here that the speed of what? The speed of Vn will be greater than speed of Vm. So overall, the relation will be what? VL is greater than Vm, but Vm is greater than, hmm, this one and this one. So how you will say like which one is greater in VL and Vn? Because in this case the light bends more, and in this case light bends less. So you can say that VL is going to be higher than Vn than Vm. So from this relation you can say as B is right answer. Okay, now question number 6th. Which of the following could result in a ray of light undergoing total internal reflection? Okay, undergoing total internal reflection. When light travels from denser medium to rarer medium. Okay, when light travels from denser medium to rarer medium, in that case, total internal reflection occurs. Okay, so you can see here, this is rarer medium, this is denser medium, and again this is rarer medium. So denser to rarer medium means when light travels from denser medium to a rarer medium, it can do what? It can do total internal reflection. So you can say here, when light travels from M to L, when light travels to M to L, okay, light travels from L to M. L to M means what? L to M. It's rarer to denser. No, it won't. Light travels from L to N. It's here, so you can't say B also. When light travels from M to L, M to L, denser to rarer. Yes, it can be, but we have to check this one also. Like N to M. When light travels from N to M, this is a rarer and this is a denser. No. When light travels from M to L. So C option is right option. Okay. Now question number 7. The diagram shows how displacement varies with distance along a stationary wave at two instants of time. This is displacement versus distance graph. You can see a wave is doing like complete period up and down, and here are 4 points W, X, Y, Z. And now, which of the following statement is correct? Which of the following statement is correct? That W and X are in antiphase, W and Y are in phase, X and Y are in phase, or X and Z. This is X and this is Z in antiphase. So see, in case of W and X, this particle wants to come down, and this particle also wants to come down. In this case, this particle wants to come down, but this particle wants to go up. Okay, now this particle wants to go up. So here you can say these two particles are in antiphase, because these two particles are in phase, these two particles are also in phase. So the only antiphase particles are these X and Z, because here the particle wants to go downside, but here the particle wants to go up. Okay, to wants to go up. And in this form you can check, here this particle will also want to go down, and this particle also want to go down. So you can say in question number 7th, like D as your correct answer. X and Z are in antiphase. Now question number 8. The graph shows how current X varies with potential difference V for an electrical component, which component is represented by this graph? A. Diode, filament lamp, ohmic conductor, or thermistor. So first, diode graph is like this. It's look like this. It is okay. Touching. It's touching. This is also touching here, and it's like this. I mean, it will go much like this, not like this. And this is a part of this. So you can say as A is correct answer for question number 8, diode. Question number 9th now. Two waves of wavelength lambda are produced by same source. Means same source, if we have same source, means we can say that the waves are coherent. Okay, the waves travels different distance and then meet. Okay, at the point where they meet, the path difference of two waves is lambda by 8. The path difference is lambda by 8. Which of the following is the phase difference in radian between the two waves? Okay, path difference is given, and now I have to do this. Path difference. So as we know, for lambda, the phase difference is 2 pi. Okay, so for lambda by 8, the phase difference will also divides by 8, so it will be pi by 4. So okay, you can say here pi by 4 as B correct answer. Now the last one for section A, question number 10. A light depends on resistor. A light depends resistor LDR and a fixed resistors are connected in a circuit as shown. Okay, this is a resistors and this is LDR. The intensity of light incident on the LDR is increased. This is the incident light. Increased the intensity, okay, on NDR. Which of the following does not takes place as light intensity increase? So option A, the current in the circuit increases, and we have to mark not, okay, does not takes place. But LDR, when a light incident in intensity increases, its electron increases. Okay, electrons increases, number of conduction in electrons increases, and when the electron increases, the current in the circuit increases. Okay, so this one is right answer. I mean, this statement is right, but we have to mark the wrong one, so you can indirectly say this is not the right answer. The potential difference across the fixed resistor increases. Okay, what is voltage across this? The voltage across this is the total current in the circuit multiplied the resistor. So if current increases, so overall the potential difference across a fixed resistor will also increase. So you can say B also right statement but wrong answer. Okay, the total power dissipated in this circuit decreases. The total power dissipated in the circuit decreases. So power is equal to epsilon into I, the current. So current increases, but you are saying, but in this question option, total power dissipated in the circuit decreases. It will increase. So C will be wrong option. I mean C is wrong statement. Therefore, it's a right answer. Now the resistance of LDR decreases. Yes, as it will release more electrons, it will convert it into like behave like a metals, and metals have less resistance. So resistance to LDR decreases. So this is also a right statement. So I hope you have understood